in a lot of ways in the industry. For example, I did some AI consulting for computer vision.
Yeah.
A lot of my times, the value that I brought to the company was telling them not to use AI. It wasn't like I was the AI expert and they described the problem and I said, don't use AI. This was my value add. Gradual loss of control and understanding of what's happening. And I think that's actually the most likely outcome probably, is that there will be a gradual loss of understanding of, and we'll gradually layer all this stuff everywhere and there'll be fewer and fewer people who understand it. And then there will be a sort of this like scenario of a gradual loss of control and understanding of what's happening. That to me seems most likely outcome of how all of this stuff will go down. Not even a single like entity or something like that, so that just sort of like takes over everything, but actually like multiple competing entities that gradually become more and more autonomous, and some of them go rogue and the others like fight them off and all this kind of stuff. And it's like this hot pot of completely autonomous activity that we've delegated to. I kind of feel like it would have that flavor. A lot of these things, I mean, they will be tools to people, and the people some of the population is like, they're acting on behalf of people or something like that. Yeah. So maybe those people are in control, but maybe it's a loss of control overall for society in the sense that of like outcomes we want or something like that, where you have entities acting on behalf of individuals that are still kind of roughly seen as out of control.
Yeah.
I would say there's like 3 major classes of how people interact with code right now. Some people completely reject all of LLMs and they are just writing by scratch. I think this is probably not the right thing to do anymore. The intermediate part, which is where I am, is you still write a lot of things from scratch, but you use the autocomplete that's basically available now from these models. So when you start writing out a little piece of it, it would autocomplete for you, and you can just tap through, and most of the time it's correct. Sometimes it's not, and you edit it. But you're still very much the sort of architect of what you're writing. And then there's the vibe coding, hi, please implement this or that, enter, and then let the model do it. And that's the agents. I do feel like the agents work in very specific settings, and I would use them in specific settings. But again, these are all tools available to you, and you have to like learn what they're good at and what they're not good at and when to use them. So the agents are actually pretty good, for example, if you're doing boilerplate stuff. Yeah. Boilerplate code that's like just copy-paste stuff, they're very good at that. I do feel like I have a hard time differentiating where AI begins and stops, because I do see AI as fundamentally an extension of computing in some pretty fundamental way. And I feel like I see a continuum of this kind of like recursive self-improvement or like of speeding up programmers all the way from the beginning. Like even like I would say like code editors. Yeah. Syntax highlighting, syntax or like checking even of the types, like data type checking, all these kinds of tools that we've built for each other. Even search engines, like why aren't search engines part of AI? Like I don't know, like ranking is kind of AI, right? At some point, Google was like, even early on, they were thinking of themselves as an AI company doing Google search engine, which I think is totally fair. And so I kind of see it as a lot more of a continuum than I think other people do. And it's hard for me to draw the line. And I kind of feel like, okay, we're now getting a much better autocomplete. And now we're also getting some agents, which are kind of like these loopy things, but they kind of go off rails sometimes. And what's going on is that the human is progressively doing a bit less and less of the low-level stuff. For example, we're not writing the assembly code because we have compilers, right? Like compilers will take my high-level language in C and write the assembly code. Yeah. So we're abstracting ourselves very, very slowly. And there's this what I call autonomy slider of like more and more stuff is automated, of the stuff that can be automated at any point in time. And we're doing a bit less and less and raising ourselves in the layer of abstraction over the automation. So reinforcement learning is a lot worse than I think the average person thinks. Reinforcement learning is terrible. It just so happens that everything that we had before is much worse. Because previously we're just imitating people, so it has all these issues. So in reinforcement learning, say you're working with, you're solving a math problem. This is very simple. You're given a math problem and you're trying to find a solution. Now in reinforcement learning, you will try lots of things in parallel first. So you're given a problem, you try hundreds of different attempts. And these attempts can be complex, right? They can be like, oh, let me try this, let me try that, this didn't work, that didn't work, etc. And then maybe you get an answer. And now you check the back of the book and you see, okay, the correct answer is this. And then you can see that, okay, this one, and that one got the correct answer, but these other 97 of them didn't. So literally what reinforcement learning does is it goes to the ones that worked really well. And every single thing you did along the way, every single token gets upweighted of like, do more of this. The problem with that is, people will say that your estimator has high variance, but it's just noisy. It's noisy. So basically, it kind of almost assumes that every single little piece of the solution that you made that arrived at the right answer was the correct thing to do, which is not true. Like you may have gone down the wrong alleys, until you arrive at the right solution. Every single one of those incorrect things you did, as long as you got to the correct solution, will be upweighted as do more of this. It's terrible.
Yeah.
It's noise. Humans collapse during the course of their lives. This is why children have completely, they haven't overfit yet.
Yeah.
And they will say stuff that will shock you because it's kind of, you can see where they're coming from, but it's just not the thing people say.
Yeah.
And because they're not yet collapsed. But we're collapsed, we end up revisiting the same thoughts. We end up, saying more and more of the same stuff. And the learning rates go down. And the collapse continues to get worse. And then everything deteriorates. The powerful idea of self-play, in my mind, is extremely powerful. So evolution actually is a lot of competition, basically, driving intelligence and evolution. In AlphaGo, more algorithmically, like AlphaGo is playing against itself, and that's how it learns to get really good at Go. And there's no equivalent of self-play in LLMs. But I would expect that to also exist, but no one has done it yet. Like, why can't an LLM, for example, create a bunch of problems that another LLM is learning to solve? And then the LLM is always trying to serve more and more difficult problems.
Right. What LLM culture might look like?
So in the simplest case, it would be a giant scratch pad that the LLM can edit. And as it's reading stuff or as it's helping out with work, it's editing the scratch pad for itself. Why can't an LLM write a book for the other LLMs? That would be cool.
Yeah.
Like, why can't other LLMs read this LLM's book and be inspired by it or shocked by it or something like that? There's no equivalence for any of this stuff.
Interesting.
When people talk about AI and the original AGI and how we spoke about it when OpenAI started, AGI was a system you can go to that can do any task that is economically valuable, any economically valuable task at human performance or better. Okay, so that was the definition, and I was pretty happy with that at the time, and I kind of feel like I've stuck to that definition forever. And then people have made up all kinds of other definitions, but I feel like I like that definition. I expect the data sets to get much, much better because when you look at the average data sets, they're extremely terrible, like so bad that I don't even know how anything works, to be honest. Like, look at the average example in the training set. Like factual mistakes, errors, nonsensical things. Somehow when you do it at scale, the noise washes away and you're left with some of the signal. So data sets will improve a ton. It's just everything gets better. So our hardware, all the kernels for running the hardware and maximizing what you get with the hardware. So NVIDIA is slowly tuning the actual hardware itself, tensor cores and so on. All that needs to happen and will continue to happen. All the kernels will get better and utilize the chip to the max extent. All the algorithms will probably improve over optimization, architecture, and just all of the modeling components of how everything is done and what the algorithms are that we're even training with. So I do kind of expect like just everything. Nothing dominates. Everything plus 20%.
Right. Interesting.
Is like roughly what I've seen. Pre-AGI education is useful. Post-AGI education is fun. And in a similar way as people, for example, people go to gym today, but we don't need their physical strength to manipulate heavy objects because we have machines that do that.
Yeah.
So they still go to gym. Why do they go to gym? Well, because it's fun, it's healthy, and you look hot when you have a six-pack. I don't know. I guess so I guess what I'm saying is it's attractive for people to do that in a certain like very deep psychological evolutionary sense for humanity. Yeah. And so I kind of think that education will kind of play out in the same way. Like you'll go to school, like you go to gym.